Hello, welcome. Today we will be studying surd. Yes, surds. Surds are irrational numbers. Example of surd include root 3, root 28. We have basic operations we do in surd. So let's start with the basic of all. Some facts you need to know about surd. When you have this kind of expression in surd, how do you simplify? What you do is you pick a very common root and mn multiplies each other to be under one umbrella of a square root. Same thing applies for root m divided by root n. All you do is convert them to this form and you pick a common root, m divides n. Basically, that's what we should know now for surds. As we proceed, we will learn better about surds. So simplification of surds. How do we simplify surds? If you are told to simplify root 45, what do you do? For the root of 45, set simplify root 45. When simplifying surds, we should always consider factors. When dealing with surd particularly, we must find out the factors in the number under the square root sign. So how do we get the factors of 45? Basically, we have a table and 45 is here. Then we write out our prime numbers. So since we have our prime numbers on the screen, can 2 divide 45 successfully? No. There will be a remainder. So 3 can divide 45. We use 3. If 3 divides 45, we have 15. For 15, 3 can also divide 15 without a remainder. So 3 divides 15, we have 5. Now we use 5 as the last number, so we have 1. To get the factors of 45, we say 3 times 3 times 5 gives us 45. Now while dealing with surd, during simplifying, what we do is we get two factors of a big number. One of the number must be a perfect square to continue our operation. So let's see how we can create a perfect square from the factors we have. Creating perfect square, we consider the two identical numbers that repeat itself, which is 3 and 3. So multiplying 3 and 3, I'll get 9 times 5 to give me 45. So if 9 times 5 gives 45, so this is my perfect square. So I'll bring these two factors into the big square root sign and have 9 times 5. The next stage will be splitting the square root for both 9 and 5. And it looks this way. If I'm to move up the next step, the square root of 9 from what we have here, 3 square gives me 9. So the square root of 9 is 3. So I have 3 for square root of 9 times root 5, and my answer becomes 3 root 5. So I have simplified root 45 to have 3 root 5. Okay, let's look at other examples too. This complex number, how can we simplify this? The same thing. I have my table, I have my complex number at this side. So if I look at this properly, I have two variables, the x and y. So let me start with the variable that has the highest power, which is x squared. If I'm dividing x squared by x, what I'm having here is x left and y. If I divide by x, if I divide with x rather, I have y alone. If I divide with y, I have 1. So factors of x squared y is x times x times y to give me x squared y. So in this situation, my complex number and my perfect square will be combination of these two to have x squared times y to give me x squared y. So if I bring it in here, I will split it to be x squared y times y. Then splitting the square root for the both, what I have is this times this. So like I said earlier when solving the first equation, the first question, the square root of x squared will give me only x. So that the square root of x squared here will give me x root y. And that is the simple form of this particular complex number. So I will drop an example for you to try out. So you can also try 3 root 5. Sorry, 3 root 50. Break this down to its simple form. What I give to you to do is 3 root 50. How do we solve this? 3 is outside the square root. So what I'll do is I'll focus on root 50. Let me break down 50 first. Let me use 2 to divide 50. My number is ending with 0, so 2 can divide it. 2 divide 50 gives me 25. The next number to use now is 5 because 5 ends this number, so 5 can divide 25. So I have 5. 5 divides 25 is 5. 5 divided 5 is 1. So the factors of 50 includes 2 times 5 times 5, which gives me 50. So to locate my perfect square, it will be 2 times the combination of these two identical numbers, which is 25. So if I'm to bring these two into this big bracket, I'm going to have 2 times 25. So that 3 times root 2 times root 25 will be equal to 3 times root 2 times the square root of 25 from here is 5. So I have 5. Now these two numbers are now in the same category, which is ordinary 3 and ordinary 5, not with root. So that 3 times 5 will give me 15 root 2. So let's push it further. There are kind of sorts where you have numbers like this and you'll be told to convert it to numbers under one square root. What do? It's like a reverse of what we have learned here. So we reverse our answer to look like this form. All you do is, if you are told to convert this to a number with a single square root, all you do is you say 2 because in solving this, we know we converted a perfect square to this single number. So we'll make this to be a square and apply a root, then multiply root 5. Next stage is root 2 times 2 is 4 times root 5. Then when you multiply 4 times 5, we have 20. Root 20 gave birth to 2 root 5. So if you have to convert this back to this is how you do it. The number outside the square root becomes a perfect square, and you introduce a square root. Then you multiply the figures inside the square root to have the bigger number outside. So you can also try this 7 root 3. If you have to solve 7 root 3 to look like this, what will be your answer? You should get root 49 times 3. So you put in your final answer. Nice. Now moving the study a little bit higher, we have addition and subtraction of surds. Surds can be added and subtracted. Now, number 1, let's take 4 root 3 plus 6 root 2. You see, we cannot add these surds because they don't have identical root. But for this case where we have 4 root 2 plus 6 root 2, can you spot the difference? Yes, we have like roots. So I can proceed with this. All I do is I pick a single root and I add up the coefficient, which is 4 plus 6, and that gives me 10 root 2. I believe you've gotten this, so you can try this on your own time. If you've tried this, what you should have is this coefficient plus the coefficient of the other side gives us 10 root 8. Good. Let's take a look at subtraction. 3 root 5 minus 2 root 5. Of course, we have root 5, and 3 minus 2 gives me 1. So our answer is root 5. Another example for subtraction, I have 7 root 3 minus 8 root 3. Or let's rather say 9 root 3. I have 1 root 3. 7 minus 9 gives me minus 2. So this is my answer for subtraction. Okay, so if you've actually enjoyed this video, please subscribe to this channel, like the video, and drop a comment below in the comment section box.